The search for oil and gas deep below the ground begins with images from space. Satellite maps point PDO's geologists towards areas where further fieldwork may pay off. When the geologists have identified a promising formation, a seismic exploration team like this moves in. The trucks roll forward together. Then at certain points, they stop and lower to the ground steel plates that send vibrations down, sometimes thousands of meters below the surface. Echoes bouncing off the layers of rock are picked up by sensors known as geophones. The signal is reflected back to the surface, where it's collected in a mobile recording unit.
Inside this cabin, there are two people. They're directly connected to the geophones, and they observe how the data is collected and how the reports are prepared and stored on tape. And then this information is sent to PDO to be analyzed and to extract the required data, which is the layers of the earth and the location of the oil.
Working round the clock enables the seismic exploration teams to double the amount of data they can collect. They also save time by means of a technique known in English as slip sweep. Seismic teams using this technique allow the signals emitted from different sets of vibrator trucks to overlap. This enables them to collect more data in a given amount of time.
Slip sweep collects the information continuously so that the vibrators never stop vibrating.
The data that has been collected in the field and processed in powerful computers is ultimately interpreted by PDO's team of geologists and geophysicists. It's a slow and painstaking business, demanding a great deal of skill and experience. The seismic signals have been turned into complex 3D images of the geological structures that often lie thousands of meters below the surface. But these structures are only hypothetical. They have to be proven to be consistent with other available geological information. The tectonic history of the depositional basin in which the structure lies, as well as the mineralogy of the rock samples and the chemistry of the hydrocarbon samples from the basin. If they believe there's a good chance that the formations may contain oil or gas, our scientists have to decide whether it's worth investing in an exploration well, and if so, where to drill it. Because in the end, that's the only way to say for sure that there are hydrocarbons in a potential reservoir, to drill into it and perhaps take core samples of rock. If any oil or gas emerges, the analysts will measure the flow rates, calculate the size of the deposits, and build a model of the reservoir. Only now can PDO decide if a field is worth developing, and if so, how. It's a laborious business, demanding huge investments. But recent exploration successes show that the company's concession area still holds significant potential for the future.